Great. Okay, so we will get started. Welcome all to our webinar this afternoon on the use of soil moisture probes and monitoring soil moisture. For those of you that have just joined us, feel free to join everybody else and let us know who you are and where you're from in the chat. And just so everybody else on the call knows as well for future networking opportunities and things. Just a little bit of housekeeping. We are recording the session this afternoon. If you've got any concerns regarding that, then just let myself or Maddie know in the chat. It will be uploaded onto YouTube and we'll share the links later this week just to enable you to either watch it back or for those that can't be with us this afternoon, they can watch it as well. We invite questions into the Q&A, which you'll find at the bottom of your screen. If you could use the Q&A function for questions, that would be great. General comments, introductions can be done in the chat function. It just enables us to pick out the questions easier when monitoring them. And I'll just introduce myself. My name's Carolyn. I'm the head of horticulture for the Soil Association, and I'll also introduce Maddie, who is our project coordinator, who makes everything like this happen for us as a team. So Maddie is behind the scenes managing all things technical. So if we run into any problems, I will be calling on her for assistance. So just to give you a brief introduction to agroecology at scale. So agroecology at scale is one of our projects we're running in the at the Soil Association. It's been funded through the online retailer Ocado, and its main function is to sort of work with farmers, growers, farm advisors to look at upscaling agroecological techniques all around kind of improving soil health, reducing inputs and increasing biodiversity. So we will kick off for this afternoon, and I will introduce the panel. Next slide, please, Maddie. Great. So our brief agenda for this afternoon is we're pretty flexible on time because we have got we've got till 4:15. So we will be I'll just introduce the panel. We've got a very brief audience participation poll to do. We're going to hear from John Taylor, the Farms Director at Pollybell Farms, and then we'll hear from Peter White from Soil Moisture Sense. There's then plenty of opportunity for discussion and Q&A. So if you have got a question, then feel free to either put it in the chat through the presentations or leave it till the end, and then there'll be plenty of time for roundup as well. So next slide, please, Maddie. Oh, sorry, that was great. So thanks for those that have done the introductions in the chat. That's really useful. And Maddie, have we got a poll just to do? This is just to give us a good indication of who we've got in the room, what our target, what our audience is. So if you could fill in the poll, so which best describes you? Are you a grower, advisor, researcher, student, or other? And which would be your main crop focus groups as well? So you've got, and that's a multiple choice, the second question. So this just enables us to get a bit of an idea as to who's in the room, area of interest, so we can look at what may be useful for kind of future webinars, events and things. So that's great, thank you. Brilliant. So what I'll do is I'll introduce the panel now. So we've got John Taylor, as I say, Farms Director from Pollybell Farms, based up in North Nottinghamshire, and we've got Peter White from Soil Moisture Sense. So John, I think in the next couple of minutes you're just going to give us a brief overview of the farm, and then we'll move on to talk to Peter.
Good afternoon, everyone. So Pollybell Farms, we farm about 1,850 hectares. The farm's actually spread across North Lincolnshire, North Notts, and a little bit in South Yorkshire. We grow about 950 hectares of organic crops, and the main focus is in organic brassicas, of which we grow about 220 hectares of organic veg. We farm as well in one part of the farm conventionally, so we get a good comparison between organic and conventional production. We have 180 million gallons of abstraction license available to us, and that's through a reservoir, 35 million gallon reservoir. We've got boreholes, we've got river abstraction, so we're pretty well covered for water throughout the growing season, and that covers most of the farm through an underground irrigation main. The farm sits on average about 1 metre above sea level to 1 metre below, and we're on peat over clay and peat over sand would be our main soil types. We've got a little bit of clay, a little bit of silt, and that's about it.
Great, thanks, John. And moving on to Peter. So I think, Peter, you're going to give us an introduction to soil moisture sense, some of the technology and how you work with John.
Yes, good afternoon, everyone. I'm just going to share a few slides, actually, just to where I can find them. Just so I don't forget, really. Where do I do that? I put that up to full screen size, do I? How do I do that? Can't see.
It's just on the bottom right, I think, Peter. It looks like there should be like a little.
Oh, that's it. Yeah.
There it is.
Okay. Good afternoon, everyone. I started off my life as a fruit grower in Suffolk, and in the 80s, I suppose, we put in irrigation systems. And when I spoke to the experts of the day about knowing when to irrigate these crops, there really wasn't any knowledge in the UK at all. Cutting forward a little bit, I came across the neutron probe as a monitoring system. I bought one of the first ones in the UK, and realized that it was quite a useful tool for other growers. So I started developing it as a business for other people. And gradually it took over my life. And here I am, God knows how many years later, still doing it. And I'm way past retiring age, but I'm doing it because I love what I'm doing. In the early 90s, I came across an Australian company called Centec, who developed an extremely clever bit of monitoring kit using electronics for measuring moisture at different depths. And it transformed the whole world of monitoring. And I became their first distributor in Europe. Since then, the business has grown quite considerably. We became Soil Moisture Sense in 2011, with a couple of my employees became shareholders. And we took on another shareholder in 2017, as he was a local vegetable agronomist and was able to give us a lot of expertise that we perhaps didn't have. We now have 12 full-time employees, 6 self-employed staff. We have a main office in Suffolk and 1 office and workshop in Kent. And we offer continuous support and service with every sale. You'll gather more about it when we go, but we give complete decision support. So growers don't have to sort of become experts on all this. They learn through us, and that's how we work. So I think that's far enough for now. I will stop sharing and we'll talk about it all a bit later. Thank you.
Great, thanks, Peter. So I apologize, I should have touched on this in the introduction. So Pollybell is one of our demo farms in the Agroecology at Scale project. And after an initial kind of opening of the learning network hosted at Pollybell for the Field and Veg Learning Network, one of the topics that came out of that was of interest to attendees was kind of around the soil health and water usage. So that's really where this webinar has come from. And with the conditions that we've seen over the summer, with sort of relatively low rainfall and some drought conditions in some areas, then we thought that it would be worth having a bit of a season overview with John and Peter. And we're going to look at some data and just have a general discussion about how that data is used, what it can tell us from some of the soil moisture probes and in on-farm weather stations, what the decision-making processes are, and any of the limitations and things around the equipment and how it can be used. So Peter, I think you're going to lead us on that discussion, aren't you?
Okay, do you want me to go first?
Yes, please.
Okay, I'll bring up another presentation. Oh. Right, can everyone see that? I hope that's all clear. Our business really is field crop. In this case, we do all sorts of crops in glass houses and everything else, but I won't talk about that today. This is field crop irrigation scheduling, the hardware and software that we provide, and the fact that we do this with full decision support. We use these soil moisture probes, as I said, that are made by Centec in Australia, and they are extremely clever because one of the biggest problems for people installing probes is installing them properly so you get sensible readings. And we're quite often asked to look at people's data from other equipment that's out there, and we often say to them, look, you can't make any sense of this because they're not installed properly. The ones we use are actually very clever. They're tapered, and using a tapered auger, and as you see in the middle here, we've drilled a hole, and as you push the probe in, it gets a tighter and tighter fit. If you have air gaps, you finish up with water running down the side of the probe, and it gives you false readings. The whole business changed hugely in the late 90s when mobile phone technology became more normal, and we were able to get the data remotely. Up till then, we had to go around and download data loggers with a laptop. And in those days, believe it or not, laptops were incredibly slow and cumbersome and troublesome, and it was a nightmare. But the mobile phone network made an enormous difference. And now we've got many thousands of these systems around not only the UK, but abroad. And the mobile phone system, which is kept going because it's important to everyone in the world, it's being kept going by really big companies so that they very rarely fail. And if they do, they put them right very quickly. So we have very few occasions when we lose signal and therefore lose data. So I'm going to rush through this a bit because it's difficult to talk about this subject in a fairly short period. But as you can see on this graph, down the left-hand side, we've got moisture content. Where the soil is in the blue, it means it's overfield capacity and drainage will occur. Then the green is when the plant is able to get enough water for its needs. And then when it gets down to the red, it's when the water use starts to slow down through lack of water. So there's all sorts of provisos on that, but that is the basics of what we're talking about. So you'll see some stuff in a minute which explains it a little bit more. But there are people who will argue about where the line should be and so forth. But I think with a lot of experience, I think we're very confident of where we put them for the different crops. Most crops take water pretty efficiently, and provided you've got a good root system, then the plant will be happy to quite a reasonable deficit. Now, this graph, can you see my mouse moving?
Yes, we can.
Okay, fine. Okay, this is a crop in the UK in 2013, so you can see it's a pretty old slide. And you can see the moisture content at 10, 20, 30, 40, and 50 centimeters in this case. You can see rain or irrigation events, and you can see how they've wetted up the soil right down to these depths. You can see water use by the plant. Now, water use is identified by stepping. and it is day and night water use. So during the night, the plant is not using water, so there's very little water movement. During the day, the crop is drying out, and the amount it dries out in the day depends on the weather. I imagine you're all familiar with ET. Evapotranspiration is a calculation based on temperature, humidity, wind speed, and a few other things. So on a hot, sunny day, a crop would be using a lot of water. On a cold, miserable day, it will be using comparatively little. But you can see here, we've now got stepping at 10, 20, and 30 centimeters. Good irrigation fills the soil up to 10, 20, 30 is not quite perhaps back to full, but it's pretty close to that. And very little water goes down to 40 centimeters. You can also see when the crop runs out of water because the stepping stops. And about this time, water use starts a little bit at 40 centimeters. But as you can see, the size of the steps there are very, very small compared to at higher depth, higher levels. Then an irrigation, good water use, 10, 20, 30. But look at the water use at 30 centimeters as an example. No water use at all, but as soon as we put water down there, the plant says, oh, we can grow now. And away it goes, then it runs out again. So each level has a full and a stress level. And if you've only got some of the levels got enough water, the plant will be struggling. So this now becomes a wonderful example. This was probably rain. It wetted the top and just about reached the 20 centimeter layer, which is probably gone down 12 centimeters instead of stopping at 10. Then it ran out of water again, stopped. No water got down to 30 centimeters. And you can see during this period, there's no water use at 30 centimeters all through this growing period. These irrigations were wetting the 10 and the 20, but didn't get down to 30. And between each irrigation, they were running out of water. So these were really bad irrigations. And this is now the sum of that same data, the top 30 centimeters. You can see the crop ran out of water, so it needed probably 25, 30 millimeters of water putting on there to put it back to full. Then they would have used that. Then this was a good irrigation or rain, whatever it was. Good water use, probably rain again. Then it runs out. And you can see stop-start irrigation right through this growing season. Now, for some crops, that's disastrous. You'll get potatoes cracking, you'll get tomatoes splitting, strawberries splitting. Stop-start is very bad. I don't pretend to be an expert on broccoli, so John will talk about that when he has his chance. But I suspect, like most crops, they don't like stop-start. They need to grow at an optimum speed. And if they're growing at an optimum speed and taking up water optimally, then the chances are they're taking up nutrients correctly. And therefore, as long as you've got enough nutrients in the soil, your crop will grow to the correct requirement. Again, we don't pretend to be agronomists for every crop. We don't pretend to be nutritional experts or disease experts or anything else. But as I indicated, I've been doing this for a long time. So not only myself, but a lot of my team have got quite good expertise. And in fact, we've just taken on a new agronomist who has got a lot of expertise, because what we realize is that growers need more help. They can look at their data, but unless they've got a lot of time to learn and understand it, they miss some of the things. So that is really the principle of what we're talking about. The data, as I say, is sent automatically through the mobile phone network to our servers. It is then displayed online for you to view. We also supply a daily email so that when growers are out in the fields and perhaps they haven't got a phone signal, they can bring up their emails and see their data. We've got lots of clever ways of displaying data, including things like this or graphs and what have you. We also use satellite data for showing people where they've missed irrigation. And if I've got time, I'll come to that in a little while. So that is what we're doing. We're collecting data and displaying it. So we're monitoring it. We can use this data for automation, although we're not doing it in field scale because of moving irrigators and so forth. But we're helping with decision support. We're also looking at root zone development, daily water use, leaching, infiltration, salinity, and onset of stress. I can come back to any of these topics if I miss them out later on if we get in question and answers. So this is a typical graph for a grower, and you can see very good water use, a small irrigation, and you can see because only a few roots got some water, the crop actually grew very slowly. Then a better irrigation, better water use, good water use. But once you get the soil full between irrigations, then all the roots become active and therefore you get big water use. So this is very, very good water use. We can also do fancy things like putting growth stages in the graph, so you know what stage you're at. And we can also put photographs of your crops in the field so we know what they look like when we look back, see what stage they're at. So for example, in a potato crop, when they're just emerging, when they're meeting in the row, when they're meeting across the row, when they're flowering, when they're beginning to senesce, and so forth. Very useful when you want to look back. Now, this is some of the Pollybell data from last year. The trials that we did, John will explain a little bit more about it because I only know what I've been told. But this is strip tilled with muck. And on the left, you can see water content at 10, 20, 30, 40, 50, 60 centimeters. You can see the soil was a bit dry when we put the probes in, probably because you can't go through planting and cultivating until the soil has got reasonably dry. And I'm sure a certain amount of cultivation will dry the soil up. So then I suspect this was an irrigation, a 15mm irrigation, just to keep the plants going nicely while they're developing a root system. I suspect this might have been another irrigation followed by some rain. I don't remember us having rain in May, but it must have done. And then you can see here we've got water use at 10, 20, and a little bit at 30 centimeters. Then we've got a bit of rain probably, then another irrigation. That was a 25mm irrigation. We always put electronic rain gauges on our systems because, as you can see, this 15mm of irrigation wetted up 10, 20, and 30, whereas this 25 didn't do. Now, there's lots of explanations about this. It may well be that the soil had cracked by that stage and the water was running down the cracks and going away from where the probe is. This sometimes happens. Sometimes when you've got cracks, you see the soil wetting. Well, in fact, I'll show it to you in a minute. So we've got water use at 10, but it really hasn't changed anything at 20 and 30. And then I would suggest the crop got too dry at this stage. And that was that pretty difficult period. I'm sure John will remember it during the latter half of June when the temperatures were sky high, everything needed irrigating. And it may well be that this crop was at a stage where it could cope with a bit of lack of water. We're also hoping, of course, that if the crop runs out in the top, it will start to root deeper. But there really isn't much sign of that in this crop. And it may be that this was in a field that had probably got sand underneath. I don't know whether that was the case, John, but there probably wasn't that much water down there, and probably the roots didn't like it. And of course, sometimes when you've got sand underneath black soil or silt or something like that, it can often be that the sand at depth is very acidic. So it may be the plant goes down there and says, I don't like this, so I'm going to not root down there. But as soon as we get water on, away it goes. And in fact, when we got a reasonable amount of water down at 20 centimeters, immediately we got some water use. So this tells a story. And this is really what our business is about, is helping the growers to understand what's happening. Now, this irrigation is about 20 millimeters. It wetted the 10, didn't have much effect at 20 and 30, but it had an effect at 40, 50, 60. And I suspect the water was just running into either the low points of the field between the plants or maybe down cracks and avoiding different areas. And I know quite a bit about John's farm, and there's all sorts of idiosyncrasies in the different soil types and the way they behave. And what works in one field one year doesn't necessarily work in the next field next year. So it's a continual learning process, and I suspect we don't know all the answers yet. The graph on the right is showing you the sum of the top 30 centimeters, which is the main rooting depth, as you can see. And you can see good water use, good water use, good water use, and then a bit of a run out, then good water use and good water use. And again, maybe this is a discussion for later, John, to discuss whether stress at a particular time is useful for encouraging the broccoli to start flowering and to start making its head, whether that helps. Certain crops, certainly onions, we try and stress them to get them to start bulbing. And it may well be that something like that occurs with broccoli. I don't know. I'm not a broccoli expert. So how long have I got, Carolyn?
Yeah, you've got another sort of 10 minutes or so,
Okay.
Peter, 10,
Okay,
15 minutes.
fine. Okay, I'll move on to the next slide. This is the ploughed and muck treatment. And you can see here the data looks a little bit different. You can see these early irrigations and the rainfall. But until this point, we really didn't get that much water use. It's only after probably an irrigation, or maybe that was an overlap because we got two irrigations going at once. Maybe that was an overlap. And you can see it wetted right down through the profile, but nothing too much. We're not too worried about it. If you're trying to convince the Environment Agency that you're not leaching nutrients into the river courses, having this sort of data and saying none of my irrigations went down below 30 or 40 centimeters is quite a good selling point, because farmers are always being blamed for nutrients getting into the water courses. But if you could say, well, it's not us, sir, it must be somebody down the road, it's quite useful. But what is interesting to me about this graph is from this point on, we really got very good water use at 10, 20 and 30 centimeters and some down at 40. And then we had a big irrigation by the look of things, or some rain, and the crop stayed pretty wet, reasonably wet, right through till harvest. Again, John and I haven't discussed this crop. We haven't had our end of season review, which is something we always try and do, to discuss what we think happened in these points. And this is why it's important to keep as many records as you can, so we know what actually happened here, for example. And one of the things you can do with the software is you can actually put a little voice box on there saying this was actually an overlap, the irrigator was put in the wrong place, or the wind was blowing, or something like that. And equally, for every time you get an overlap, you often get a bit that's missed. So uniformity of irrigation is incredibly important. And I will show you something in a minute which explains all of that. So we've got some data, and we've got some interesting data, and it will only be when John and I can discuss what we've produced and what we've learned that we'll really have the final answers. So let me move forward again. This is some data from Pollybell crop in 2024. And what is interesting here is we've got extremely good, strong water use right through the period. Early July was obviously quite wet. There were lots of dribs and drabs of rain. And we've got really good water use down to 40 centimeters, even at 50 centimeters here. Now, I would imagine that that was a very good crop, but whether John could remember back that far to RL2, I don't know. But it was a pretty good crop. And one of the things we try and do when we're doing our review is put all the fields that we've monitored into a list of the most productive and the least productive, so we can look back and see why that was the least productive, whether it was something to do with water. It could be other things, of course, like disease or lack of foliage, or a lot of disease and things like that, pests, so forth. but it's surprising how often the best watered ones become the best yielding ones. This is one of these little voice boxes that we can put on, and if you click on that on the software, it tells you what actually happened there. So here, yes, what we were wondering was whether early irrigations prevent rooting, and I'm not sure about that. I don't necessarily believe that's the case, but plants will only go deeper when they need the water. But if they develop a big root system in the top 30 centimeters, well, they probably won't bother to go down finding any more, provided they've got enough water. But again, one of the things you see in the graphs quite often is you see a flat line at one particular level, and this is often a pand. I couldn't actually find any in your data, John, so that's a good sign. I was looking for it, but sometimes we'll see, certainly in ploughed crops, at the bottom of the plough, maybe at 30 centimeters, we've got just a flat line, no water use because it's just a rock hard pan and the roots can't go through it.
Peter, would you like me to come in just on the previous slides with it,
yes.
to put a bit of depth to the results? I think the one showing the strip till and the one showing the muck, probably the most interesting.
Yeah.
So we ran a trial this summer looking at strip till broccoli into a clover mulch, and in the same field we had a ploughed section, so we just produced a crop as we would normally in the field and compared the two. So that was the two graphs that we just looked at for water usage. You were absolutely right, there's a sand level underneath the topsoil in that field, which showed the water usage. But what we also found is that we struggled to get the broccoli to develop a decent root system. Now, clover as a companion living mulch with broccoli is not the ideal crop. What we were trying to achieve was look at the nitrogen that we could get out of the clover mulch and see if that would assist with the fertility in the growing crop. And where it tails off, because we were only doing sort of 1/4 of a hectare blocks, it's quite interesting seeing it. We made a management decision to withdraw the irrigator from that trial because the broccoli was looking pretty sad. The clover was getting away from us. And at that time, we needed every irrigator on the farm to be working, flat out. So it shows, one, it's good for the rooting depth for us, and also it just showed what was happening within the strip till trial. And
okay.
We go to the ploughed section, and you can clearly see there's better water usage through the full rooting depth of the plants. And because that crop, worked well through the summer season, we kept irrigation going because it was financially viable for us. But for us, it's quite an interesting snapshot of what happened between a strip till brassica crop and also our general method of farming would be to plough the clover down. So it definitely showed where the root depth we're achieving within the ploughed section. And I think then looking at previous years in 2024, I still think we've got to look at the early application of irrigation in our soils, because you're right, we'd normally see good water usage down to 50 centimetres. So we pride ourselves in making sure we get good rooting depth. The brassicas can find nutrient, they can also find water at depth. And what we've seen throughout this season is, water usage in a lot of the crops down to sort of 30 to 40 centimetres, but not much lower. And given the season we've had, most of the crops being irrigated from the stage at planting all the way through. So we do wonder if the constant application of irrigation did in some ways stop the crop from looking for water further down.
Yeah. Okay, that's interesting. Did you see any benefit from the clover?
We saw an element of fertility in the crop, but in our sort of continuing trials, I think the value of the nutrient in the clover being ploughed down into the land is of more benefit than the companion cropping in a strip till system for us. And also the investment in the machinery that we'd require to grow the crop in that method. Financially, it doesn't stack up for us at the moment.
Yeah.
So, but we're going to continue with the trial to look at clover again in our rotation as a fertility build pre-brassicas, and how much nitrogen we can fix through a clover crop.
Yeah. Okay. Shall I just carry on quickly for a few more minutes?
Yes, please.
One of the things that's interesting at Pollybell, they have, as John's mentioned, a pretty big farming operation, and they've got 2 of our weather stations. How many miles apart as a crow flies, would you think, John? You're on silent, sorry.
Yeah, probably more like 12 miles, I suppose, as the crow flies.
Yeah, but it's all flat, isn't it? You'd expect it to be pretty similar rain, but this was the rainfall in July between the 2 sites, and one had 76 millimeters and one had 117. So vast variation across a very small area. And I think when you're managing crops, having that data is very, very useful. If it might save you an irrigation, might save you a bit of work. Certainly irrigation is an expensive pastime these days, and so we need to avoid it. One of the things I wanted to stress about deep rooting is that if you've got roots down to 50 centimeters instead of 30, you've probably got an extra 30, 40 millimeters of water that's in the soil that's there for free. If you can use it instead of having to pump it, it would save you a lot of money. So rooting depth is very, very important, and ultimately it's about profit. So we're trying to increase profit through a whole range of things. It's not just irrigation. There's a whole lot of discussion points here I wanted to talk about, but I'll come back to them in a minute if I can. I mentioned satellite view, and built into our software we can show NDVI, and NDVI is basically showing you greenness. And those of you who don't know, if you've got this dark reds and oranges here, the crop is pretty well half dead. Dark green is what you're aiming for, and somewhere up here is acceptable. And you can find out what's happening. This is a pivot, and you can see variations across the field. But I wanted to just show you an example of one field that we monitored with potatoes. This is their satellite data through the season, and you can see here stripes occurring even in June. And these were where the irrigator was not working well enough. It wasn't overlapping, it wasn't meeting, it was a rain gun. You can see here's a dark green area that's on there for most of the season. And that was pretty interesting. No doubt the grower could improve it by better management. But what we were interested in, this particular grower had a yield monitor on his potato harvester, and that's what he got. So you can see dark blue, which is where I was showing you dark green, was in excess of 72 tons per hectare. The field averaged 38 tons a hectare. And you can see all these, now that's just laziness and bad irrigation. And I can't, let me get rid of you there. What could you do to overcome it? First of all, it may be just that the rain gun pressure's wrong and it's not throwing the water as far. It may be you're trying to run 3 irrigators from a pump that really should be only working 2. Maybe you've got the wrong nozzle size in for the pressure. Maybe your run widths are too far apart. There's all sorts of things that could be going wrong, but that was down to just bad management. And we had a probe in somewhere about here, so we were above average with what was happening. But if we'd have been here, we'd have said, what on earth are you doing? You're doing a dreadful job. And we've got growers now who are putting more probes in fields so they can get a better cover. And we've got one grower who's got a linear move irrigator, and of course he doesn't miss any of the field, and he's producing very, very big yields. I put some figures in to look at the economics of this, and you can look at them later. But basically, I put in some rough potato growing figures, and I suggested this grower would have made more profit if he only grew 10% of the area and did it properly. So, wow, the economics of good irrigation are incredibly important. So I wanted to show you that because it's so mind-blowing. We haven't got any satellite views of John's fields, but we can always go back and get them if we want to, if there's things we want to look at. So let me go back to these discussion points. Shall we discuss these at the end, Carolyn? Do you think?
We haven't got any questions yet, Peter, so feel
No, well,
free to...
if when John has finished, we want to have some points, we can go through these, and if you like, or I can talk about them now very quickly.
Was there anything you wanted to refer back to again, John, on the data that Peter's presented?
Not unless there's any other questions. I think, you know, Peter's made some valid points just on that last slide about the application of irrigation. And I've been speaking to Peter about this, and I think sometimes, and we're guilty of it, is the team in our fields that are managing the irrigation and putting the reels out. I think we need to do more from a training point of view. So we make sure that the irrigation is done, you know, as best as we can do it. And I think it's clear this season, it was quite a windy season as well. So we had to constantly move our irrigation pools to manage any missed areas. So I think the effectiveness of rain and irrigation, we no rain. It's interesting, the slide showing our rainfall. I think up until that point, we'd had 135 mils for the season, and with 117 mils over 2 weekends, basically. But on our soils, that came in, say, two dumps of rain, sort of 50, 60 mils, I think over the space of probably 15 days, something like that. We were back irrigating after the second rain event within 7 days on our more advanced crop, because we struggled all season to get the soil profile to capacity. So, you know, with a dry season and the drought we've had in our soils, it just goes to show in a normal year, 117 mils would be quite significant during the growing season, and it barely touched the sides, you know, through the summer. Do you want to talk about, we'll go back to rooting depth and how we think it's affected by irrigation. Again, you know, we're still learning, and it's something that Peter's mentioned to us this season. And I think we've got a bit of work to do with that. I'm pretty sure we didn't have compaction in our soils. Our soils don't really see a pan, you know, in our rotation. And I do wonder if it is sometimes down to the fact that we are continuously irrigating crop from planting through to harvest. So yeah, there's a lot more we can learn, I think, and look at with the different seasons. You know, I've been on this farm 10 years, and every season throws up something new. And this has definitely been one of those seasons.
Okay, can I just ask a question, John? When you're planting your plants, are they presumably are they in peat blocks?
They're in peat blocks, and we water all the blocks before they go out to the planter.
Yeah.
So we'll pre-water, but on our peat soils, you know, once we've worked them ready for planting, you know, they're pretty dry, depending on the temperature as well. And it's something that I think we need to look at is more temperature probes in the soil, just to look at the soil temperatures. And we tend to plant them, and then they'll get probably 12 mils just to water them in. And we found this season we'd probably have to follow again 5 days later with another 12 mils. And if we get them established, then we tend to leave them for a few weeks. But this season we've been sort of back in again within a fortnight, just, you know, watering again. So.
One of the questions I wanted to ask was, I've seen this before with lettuce crops when the plants come in trays and the plants got a bit too big, the taproot, instead of, when it gets to the bottom of the tray, obviously it can't go any deeper, so it turns at right angles. And what I've seen with lettuce is that taproot never straightens up and starts going down again. And that has an effect on the rooting depth. Hopefully your plants are not that big that they do that, but it may be that if the plants are growing too quickly and you can't get them planted, it may be something like that happens. I don't know.
I see we've got one question on rooting depth. So rather than type an answer, I can just deal with that. Well, the water table depth rather. So on our farm, the farm's controlled by pumps. So we can pump the water out if need be. Or we've got the internal drainage board that control the main dikes. In a normal season, the water table could be, you know, a metre and a half down. In this season, I'd imagine it would have been 2 meters down. You know, if we get a big rain event, then the water table will come right up, depending on the water level in our dikes. We made a decision in 2012, before I joined the business, to put in the reservoir for winter storage of water, purely because we used to use a section of sluices and dams throughout the farm, and we'd block off all the internal dikes and hold water. And then the water would be used for irrigation purposes on the crops. And in 2012, I think the summer of 2012, they got a rain event of about 4 inches in the space of a few days. And because the dikes were dammed to hold water, they couldn't get the water off the fields quick enough. So they lost a lot of vegetable crops with flooding. So the decision was taken then not to block our dikes internally. And we'd use the reservoir water and an irrigation system. So we didn't run the risk of losing crops through flooding.
One of the things we're doing, we monitor all sorts of strange things. And one of them we're doing in the fens actually is we're measuring water table and seeing how that changes during the season. And I know around the fens they're playing around with the dikes and how much water's in the dikes and so forth. And they wanted a way of keeping a tab on what was happening. So we've got sensors that are measuring that. And I think it's proving to be quite useful. Okay. Apart from the questions, I think I've probably finished, Carolyn.
Great, that was brilliant. Thank you both. We haven't got any other questions in the Q&A at the moment, but one of the things I just wanted to get a bit of a feel on from you both was around kind of, we spoke briefly just when we were talking before at the start around kind of the use of capital grants and government, you know, funding for equipment and infrastructure. And I know, John, you mentioned that obviously you'd received capital, or the farm had received capital grants back in sort of pre-2012 for that infrastructure of the reservoir and ring main, and whether there was just any other support that you think would be beneficial to growers sort of now.
Yeah, well, back in those days, you know, that was built with an EU grant. Unfortunately, that's not available now, but there are, you know, infrastructure grants available. We haven't entered in other projects recently. As far as the equipment goes, I was speaking to Peter earlier about it, and it's the speccing up of the equipment versus the value of the grant. So we often find it's just better to go and buy the equipment to our spec rather than go through the rigmarole of trying to spec it for grant funding. Peter, do you want to come in on that?
Yes, we obviously hear from quite a lot of growers who are applying for grants for reservoirs in particular, and they like to include some of our equipment in the grant, which is fine. It works with that, and they get that. It's incredibly long-winded. You have to be very patient, but that's fine. If you haven't got a reservoir and you're going to build one, you probably don't need to be monitoring too much until you've got some water to do anything about it. But one of the things we're just in the process of doing is investigating the whole grant minefield for our customers. And anyone who would like a resume of the grant situation, they're welcome to email me, and I'll put them in touch with our guy who's doing all the work on that, because we realize the growers get terribly busy and don't have a lot of spare time. And if we can help by saying, there's a grant here, this is what you have to do, we can help you with it, or whatever else, then it might be useful. Obviously, we've got a vested interest because we hope you're going to buy more equipment, but that's what it's about. But going on to our monitoring equipment, we not only sell it, but we also hire it. We also do a 3-year rental sort of hire purchase scheme. So people can rent something for 3 years, and at the end of 3 years, they own it. And it just spreads the cost a little bit, and it doesn't make a lot of difference to us. So we're very, very flexible about the way we do it. And I know Carolyn suggested there are 1 or 2 sort of smaller growers going to be involved in this discussion. And what I would say to anyone is, if you've never monitored soil moisture, if you just have one piece of equipment and monitor a particular crop, you're going to learn a lot about irrigation. And we will help you. Part of our deal is that we give, as I say, decision support. And we're quite happy to answer the phone every day of the week if necessary, if you've got queries. And I would say to people who are not customers, you're still welcome to pick up the phone and say, we've got this problem, what can we do about it? So we are totally supportive of the whole of the farming industry. We want all our customers to be making lots of money because they spend money then, which is always good for us. We want the UK Farming Limited to become as successful as it's possible to be. So that's why we do it.
I think there's a question on drip irrigation. So from our farm's point of view and the crops we grow, and growing organic crops, we interrow hoe, so we're moving soil all the time. So drip irrigation doesn't work in our system with the amount of cultivations that we do in the brassica crops. But it definitely has a place, I think, in potato crops and crops that, probably conventional farming crops that you're not hoeing interrow. Something I think we're guilty of because we've got quite a big obstruction license. We're not challenging ourselves on the effectiveness sometimes of our water usage with the plant's requirement, because we're not going to run out of irrigation water during the season. But again, now we're looking at rooting depth. I think it's something that we've got to look at. Peter can maybe talk a little bit more about drip irrigation. I have had experience with it in the past, and it worked very well.
We work with quite a lot of people using drip irrigation in field crops, and 2025 was a wonderful year to have drip irrigation because you were only putting on the water where you wanted it. It wasn't sitting on the leaves and evaporating. I mean, this year in the middle of the summer, if you were wetting a field of potatoes with 25 mil, if you got 15 into the soil, you were doing jolly well. Whereas if you're using drip, it's all going in the soil because that's where it's being applied. The other advantage of drip in potatoes particularly is you can carry on irrigating right through until almost harvest time, keeping the ridge nice and wet, keeping the crop growing longer, and stopping the ridges cracking and therefore encouraging green potatoes. So 2025 was an amazing year, and I would say if we were going to have years like that every year, more and more people would go to drip because they would be forced to. But yes, it's more expensive, but I'm sure John would agree, irrigating with a boom, for example, and if you're having to buy expensive water and build reservoirs and everything else, it's not a cheap pastime either. So drip irrigation has a very important place, I think, in the field crop market. And ultimately, it's about making profits. And, you know, that graph the photograph I showed you about potato production, the national average in the UK is below 50 tonne a hectare. And we've got growers who are growing close to 100 tonnes a hectare. And a lot of that is down to attention to detail, of which water is an incredibly important part. And the same figures apply to onions. And I suspect that the difference between the average yield of broccoli this year and the best yield of broccoli is quite considerable. And so water is the important part. Drip is good. We can always help you. We don't sell it. We've got no interest in selling it, but we believe in it. So if you need some help or any advice, always pick up the phone and have a chat.
Great, thanks, Peter. And I've just got a question for you both around, you know, what do you think the limitations are of kind of some of the soil moisture probes? And is there anything, John, that you would do you would do differently to what you're already doing when using the data?
Yeah, using the data basically is key. And that's what I was going on about, how we need to, you know, I know internally we need to have better training on the use of the data. And when everyone gets busy, this has been a pretty testing season for, you know, the irrigation team. And I think when we get busy, there's not as much attention paid to the data that we get every morning. So it needs to go right through the management into the guys that are out there applying the water, is to utilize the data we've got, you know, and really maximize what the plant requires. And there's a lot, we've got a lot more learnings to take from this season. And it, you know, it has been a difficult season, and, you know, everybody tends to get into survival mode, and it's just about getting enough water on all your crops to keep them growing. So yeah, we've just got to sometimes step back, take stock, and utilize the data.
Yes, I think that training is something that we do for our customers. And some of the soft fruit people we deal with have got, I don't know, 20 irrigation gap managers. And some of them do a very good job, some of them do a very bad job, and the rest are somewhere in the middle. And we are more than happy at no cost to do a training session for people. We can do a remote one like this, but also we're quite happy to do face-to-face ones if it's necessary, if it would be considered better. Because what we find is that if the irrigation team understand why you're doing it and what they're doing it for and what it achieves, they become much more interested. And John, I guess what you want is your irrigation guys to say, John, I think we should be doing this. What do you think? And you say, yeah, great idea. Whereas you might not have time to even have a look at it, and they probably not confident enough to make those decisions without talking to you. So it's always difficult when you've got a chain of command. And if the boss is making all the decisions, well, some things fall by the wayside. So training is something we will do for anyone, anywhere. And we're very happy to do that. I think one of the other things we're doing a project to do using AI for interpreting data and helping people get the best out of data. Where it's going to lead, we don't know, but we've got growers who've got 100 of our monitoring probes. They monitor every field they've got. And just to look at the data is a morning's work. And of course, when it's all changing every 2 or 3 days, not many people have got that amount of time to spare. So again, our software can put everything in order of need to irrigate. So your graphs can be shown in a screen which says, this is the driest one, this is the wettest one, these are the ones you've got to concentrate on. So there's a lot that's already available there, and it's just getting people to use it better and know it's there, which is what we're trying to do. Okay.
Great, thanks, Peter. And I've just I was just going back to the question that we had submitted prior to the event. I think what Kate was asking was around, you know, what we've obviously covered, you know, the different purchase options and things. And I was just wondering about the kind of the differences in soil type variation and where you would where you'd recommend, you know, growers to place them, and whether there was an option that if you'd got a group of smaller scale growers, whether they could share equipment in some way if they were working on similar soil types.
So can I, so on Pollybell, we're working, say, 4 stations in the fields, but we put them in crops at different growth stages. So we don't have them in every field, but we'll have them close, you know, to neighbouring fields, pretty similar soil types, and pretty similar growth stages. So for us, it's important to monitor the different growth stages to look at water usage in the brassica crops. I don't think you could share them unless you were, as in neighbours across a fence, because you need to monitor your irrigation applications along with the soil moisture. And we'll look at soil types. I think one of our slides earlier was on a fairly heavy soil type. So, you know, we'll look at different soil types across the farm as well, and then judge where we're going to put them in different crops.
Yeah, I think what we say to growers is, and we have a lot of growers who are renting land, so that makes life difficult because people come into, they call us to go to a field and they don't know much about its history, they don't know much about it. First thing we can do is look at satellite data and see what we can see from last year's wheat crop. And if there's 2/3 of the field that died off very early because it was much drier than the other third, we'd say, well, we really need to make sure we're monitoring in the driest part, because that's going to reach a critical stage first. Assuming your crop is going to be using the same amount of water, whether the soil is heavy or light, then the deficits will follow the same patterns, but the heavy land will need bigger irrigations less often. And therefore, whereas a light sandy soil, for example, where we live in East Suffolk, we're surrounded by sand, and you rarely get much root activity below 30 centimeters. The water holding capacity is pretty much the same in the whole area. They have to irrigate with maximum 25 millimeters, because if they put more on, they usually waste it. But if the crop is using 5 or 6 millimeters a day and there's a bit of evaporation, they've got to be able to get around twice a week. Now, when I talk to new growers about irrigating twice a week, they throw up their hands in horror and say, we can only get around once every 10 days. And one of our customers, when I first started working with them, they bought some monitoring equipment and they phoned me up and they said, Peter, we're struggling. And I said, oh, sorry to hear that. I'll come and see you. I went to see them and they said, we're getting the data, but we can't do what it's telling us. And I said, well, let's start with basics. How many, I think it was acres in those days, are you trying to irrigate? And how many irrigators you've got? And they told me, and I said, well, you haven't got a hope in hell of doing a good job. You know, you really need 1 irrigator for every 40 acres. And that's assuming you're pretty hard working and your guys are happy to start moving irrigators at 5 in the morning and at 8 o'clock at night. If you're not in that luxury situation where your guys are prepared to work that long, then you need more irrigators so you can get them set out and do the job better. But one of my pet sayings is to most growers, why don't you do less and do it better? Because ultimately, like the potato field I showed you, if you could grow 10% of your crop and make more money, wouldn't you want to do that? So that's what it's all about. It's about profit, but there's lots of ways of getting there.
Great, thanks, Peter. So I'll there's no other questions in the Q&A or the chat. So
well, I've got a couple more things I can bring up if you like. Just
yeah, a couple of minutes.
Yeah.
2 or 3 minutes, Peter, that'd be great.
One of the things I sometimes talk about is soils getting waterlogged. And we've got some very good graphs of waterlogged fields. The water use slows down after every irrigation, and it's probably through lack of oxygen or capping. And if your crop is being irrigated every 5 days and you're stopping the crop growing for 3 of those 5 days because you're putting too much water on, you're actually not doing a very good job. So monitoring and knowing what's happening is very, very important. If we got another hour or two, I could show you some wonderful examples of what happens. But lack of oxygen is something that worries me, especially on some soils. Some of the silt soils around the fens, around the wash, they cap every time they get rain, and then very little water gets in when it rains, very little oxygen probably gets in. And actually, John, we had that experience, didn't we, on one of your other estates a few years ago, growing potatoes. You know, the history of the soil didn't help trying to grow a good crop of potatoes. And I think you have to know you've got a problem before you can solve it. So that's part of our sort of remit, saying, well, okay, we've got a problem. Let's see what we can do about it. We haven't talked about leaching of nutrients and chemicals. And again, if you're putting on too much water, you may well be leaching expensive nutrients and chemicals, which all go in the waterways, and we all get blamed for it. So very important not to overwater. And it's very easy to do it with drip irrigation, because when the drip irrigation guys are selling you drip pipe, they will tell you that the water spreads like an onion. Now, it may do in some soils, but in other soils, it spreads like a carrot and goes straight through. So monitoring what you're doing with drip is very, very important. And leaching is a problem. The other thing I mentioned earlier on was field cracking. And some of the clay soils in particular, the soils crack. And if all your roots are in the top 30 centimeters and you've got a crack that goes down to 40 centimeters, so that every time you put water on, it goes down to 40 centimeters where you haven't got any roots, then your irrigation is not very satisfactory. So you've got to put it on in the right way. Maybe you need to know at what deficits your soils start cracking, and that probably varies from year to year. So that's something we can help you with. So those are the points that I had on my list anyway.
Brilliant. Thanks, Peter. And we've just had one last question in from Philip, John, around about what's the soil analysis at Pollybell?
Oh, gosh. So roughly on our vegetable rotation land, we try and maintain P's and K's sort of 2 pluses, 3s, usually nothing below that.
Great, thank you very much. And that all will draw it to a close. So I'd just like to thank John and Peter very much for sharing your wealth of knowledge with us this afternoon and your experiences. There are links in the chat both to to the web address at Pollybell and to soil moisture sense as well. And if anybody is interested in joining the learning network, either we've got currently got one running up in Top Fruit, and we've also got one running in Field Veg and Salads, which this is part of. So feel free to drop me an email. My email address is in the chat, or you'll find me on the Soil Association website and I can add your name to the list. One thing I will just ask is we've just got a quick poll to be done. This is just around any future topics that you think you'd like to cover. If you've got any suggestions of topic areas then that aren't listed, feel free to note them in the chat and we'll download them as well. And there's also, Maddie's added a feedback form. Everybody loves a feedback form. If you wouldn't mind filling that in, there's a link to that in the chat also, and we'll send it out with an email after the event, probably before the end of the week, beginning of next week, that will have an attachment of the recording as well. So there's a feedback form, and then also there's a link to all our future events that are happening at the Soil Association website, and there's a list of those up on the screen as well. So once again, thank you very much all for joining us this afternoon. Thanks to Peter and to John, and we'll hope to see you all again soon.